Hello everyone, welcome to Maths and Science Intervention Club. My name is Mr. Nkona, a Maths and Science teacher. So today we're going to be doing organic chemistry. The topic will be all about alcohols. We are going to deal about IUPAC naming of alcohols, and also we are going to distinguish between primary, secondary and tertiary alcohols. So now here I have a statement. It defines what is an alcohol. It says an alcohol is an organic compound that carries at least one hydroxyl functional group, which it is seen as OH, which is bonded to a hydrocarbon chain. Let me just give a description of what I am talking about. So a hydrocarbon chain, it is a compound that is consisting of only hydrogen and carbon atoms, right? So now this compound is a hydrocarbon because it has only hydrogen and carbon atoms. But then if I have an OH group which is bonded to this particular hydrocarbon chain, it means I will now have my what? My O bonded to my H, because I know that oxygen can form two bonds. So now that is why I have something like this. So now if I now have a compound which is now like this, it is no longer an alkane, but then now it is an alcohol. Why? Because it consists of a what? Of a hydroxyl group. So now when it comes to naming, we also look at how many carbons are there in this particular compound. What is the longest chain in this particular compound that I have here? So now the longest chain will have one carbon, two carbon, we have one carbon and two carbons. So the longest chain is consisting of two carbons. But then if I move from left to right, this OH here, it is attached to carbon number 2. But then if I were to move from right to left, this particular hydroxyl group, it is attached to carbon number 1. So now what we do is that we prioritize the smallest number, because if we move from left to right, this OH here, it is in carbon number 2, but then if we move from right to left, this OH there becomes in carbon number 1. So now between 2 and 1, which one it is the smallest number? Obviously it is 1. Therefore when we are naming, we are going to prioritize the smallest number, which is going to be 1. Therefore, now after I've known the direction of how I am supposed to count my carbons, I am going to write it like this. So it means this carbon here will be carbon number 1, and this carbon here, it will become carbon number 2. So now when I want to name how many carbons are there within my given structure, there are 2. So 2 goes with what? It goes with it. But now this is a what? It's an alcohol. Therefore it's going to be ethanol. An alcohol, the last two letters of an alcohol is OL. Therefore we are going to write those two last letters that we have in an alcohol. Therefore we are going to have ethanol. So it can be one ethanol, or it can be one ol. It can be one ol, which is ethanol. This particular ethane, yes, ethane one ol, whereby this one shows the position of my hydroxyl group. Shows the position of my hydroxyl group. So now let me go to another and show you another example that will require us to give an IUPAC name of an alcohol. So now if I have an alcohol that has 5 carbons, then I have my OH group here, my hydroxyl group. Then this particular carbon will have 3 bonds, a hydrogen there, hydrogen, another hydrogen. So now I have my structure here, right? So now it is not an alkane, because an alkane consists of only hydrogen and carbon atoms. But then when I look at this structure here, I have a what? I have a OH group, which is an hydroxyl group. So now this makes this particular structure to become a what? An alcohol. So now if I want to name this particular alcohol, I am going to establish the longest chain. What is the longest chain here? I'm going to start counting from left to right. When I count from left to right, I have carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. But then when I start counting from right to left, also I have carbon number 1, 2, 3, 4, and 5. So now if I count from left to right. This OH group here, it is in carbon number 2. Carbon number 2. But then if I start counting from carbon number 2, this OH here is in carbon number 2. But then if I start counting from right to left, this OH, it is attached in carbon number 4. So my question is, between 4 and 2, which one it is the smallest number? Obviously it is 2. Therefore, when I now want to give naming, I have to prioritize the smallest number, making my OH group to become in carbon number 2. So I'm going to choose the one that is making the OH group to go as carbon number 2. So now I am going to make this hydroxyl group to be attached in carbon number 2. Therefore, I'm going to choose counting from left to right. So now when I name, I know that the highest number of carbons that I have here, it is 5. Therefore, 5 goes with what? Goes with pent. So I'll have pent. But then I have to account for this position of my double bond here, of my OH group. I have to account for its position. Where is it positioned? It's positioned in carbon number 2. Therefore, I'm going to write 2 here, whereby I'm going to have pentanol, 2 pentanol, whereby the 2 shows the position of my OH group. Where is it positioned? Is it positioned in carbon number 1? Is it positioned in carbon number 2? Therefore, these 2 will tell us that this particular hydroxyl group, the OH group, it is attached in carbon number 2. So now when we prioritize the smallest number that makes the OH group to be attached to the smallest number of a carbon. So now let me move to another structure whereby we have an alcohol, but then this alcohol, it has branches. So now I am going to have an alcohol here with, let me say, 6 carbons. Let me attach my OH group in carbon number 4 or carbon number 3. So now I'll have my branch over there. I will have my other branch over here. Let me just put another branch here. Yeah, this is what I have as my alcohol. So now when I want to name this alcohol, I am going to do the procedure that I was doing before. I am going to establish the longest chain, whether I move from left to right or whether I move from right to left. Which one is going to be my longest chain? So I will start here. This is carbon number 1, carbon number 2, carbon number 3. Am I done? Let me just continue and see if maybe carbon number 3 will be the longest chain. Then now I'll have number 3, number 4, carbon number 4. But then I'm not done. I have to establish and count for every carbon. So now this becomes carbon number 4. I have carbon number 4, number 5, number 6. Therefore, the longest chain here, it is going to be a carbon number 6. That is the longest chain. But then now, since I have established the longest chain, which is carbon number 6, how am I supposed to count? Am I supposed to count from left to right, or am I supposed to count from right to left? Let us see. So now if I count from left to right, this OH group here, it is in carbon number 4. It is in carbon number 4. But then if I were to count from right to left, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. This OH group becomes in carbon number 3. So when I move from left to right, it is in carbon number 4, and when I move from right to left, it is in carbon number 3. So between 4 and 3, which one is the smallest number? 3. It means I have to prioritize number 3. Therefore, I have to count from moving from right to left. Therefore, this one is out. Therefore, I have to count from right to left, because in that way the OH group is attached in carbon number 3. Now that I have the direction of when and how to count, I have to now give the name. So if I count like that, I have something which is left outside, which is this methyl group. I have another something which is left outside, which is that methyl group. So now when I want to name, I have to account for whatever that is left outside. I have to account for those methyl group. But then now I have my longest chain. Let me start by writing my longest chain. So my longest chain has how many carbons? 6. Therefore it's going to be hexa hexanol. But then I have to account for where this particular OH group it is attached. It is attached in carbon number 3. Therefore, I'll have 3 hexanol. But then me writing 3 hexanol, I only wrote for this particular portion. I did not account for my what? For my branches, the ones that I left outside. Therefore, I have to now account for them. How do I account for them? I am going to ask myself, where is this branch located? It is located in carbon number 4. And where is the other branch located? It is located in carbon number 5. So now, if I want to give the IUPAC name of these branches here, I am going to say this particular branch here, it is a what? It is a methyl. Therefore, I'm going to write methyl. But then, where is it located? It is located in carbon number 4. And where in this branch, what is it? It is also a methyl. Therefore, I have 2 of the methyls as my branches. And where are they located? Carbon number 4 and carbon number 5. Therefore, I will have 4,5 dimethyl, which shows that I have 2 of the methyl groups as my branches, whereby they are located in carbon number 4 and carbon number 5. So I will have 4,5 dimethyl 3 hexanol. That is the name of my structure here, of my alcohol. So now we also have primary alcohol, secondary alcohol, and tertiary alcohol. So now if I'm given an alcohol, how will I know that this particular alcohol, it is a primary alcohol, it is a secondary alcohol, or it is a tertiary alcohol? Let me give you this structure here. I have OH. Let me just write another carbon here. H, 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 H. So now let me also write another structure. 1, 2. I have O bonded to H. I have my carbon here. I have my hydrogen. No, let me, and my hydrogen here, hydrogen there, hydrogen there, hydrogen. So now let me start with primary and secondary alcohol, so that it will help you to develop an idea about a tertiary alcohol. So now let us look at this particular structure here, structure number 1. Let me just say this is structure number 1. So now, by looking at this structure, is it a primary alcohol, secondary alcohol, or a tertiary alcohol? How can I even see whether it is primary, secondary, or tertiary? What I do is that I look at my OH group. Here's my OH group. But then my focus will be, since I've established my OH group, I am going to look for the carbon that is bonded to the OH group, the hydroxyl group. This is the carbon that is bonded to the hydroxyl group, right? Then I'm going to ask myself, how many carbons are bonded to the carbon that is bonded to the OH group? How many carbons are bonded to this carbon which is bonded to the OH group? I only have 1 carbon. Therefore, this one will become a primary alcohol. A primary alcohol. Let me go to this second structure. I am going to say which carbon it is bonded to the OH group. Here I have my OH group, and which carbon is bonded to my OH group? It is this carbon. Therefore, I'll ask myself, how many carbons are bonded to this carbon? How many carbons are bonded to the carbon that is bonded to the OH group? This is carbon number 1 and carbon number 2. Therefore, I have 2 carbons that are bonded to the carbon that is bonded to the OH group. Therefore, this particular structure will become a what? A secondary alcohol. Does it make sense? So now let me give us an idea, using what we have learned, will you be able to tell how a tertiary alcohol will look like? It means how many carbons are bonded to the carbon that is bonded to the OH group. So if we have 1 carbon, therefore that particular compound structure will become a primary alcohol, because I only have 1 carbon that is bonded to this carbon which is bonded to the OH group. And by looking at this structure here, structure number 2, I only have this carbon is the one that is bonded to the OH group. Therefore, I ask myself, how many carbons are bonded to this carbon? It is this carbon and that carbon. Therefore, there are 2 carbons, which becomes a what? A secondary alcohol. So now when I have a structure like this, 1, 2, 3, I have my OH here, I have my carbon there, my carbon there. So now for this structure to become a tertiary alcohol, I'm going to ask myself, which carbon is bonded to the hydroxyl group? It is this one. It is this one. Therefore, I'll ask myself, how many carbons are bonded to this carbon? How many carbons are they? Carbon 1, 2, 3. There are 3 carbons that are bonded to this carbon, which is bonded to the OH group. Therefore, this structure becomes a tertiary alcohol. That is how you establish primary, secondary, and tertiary alcohol. So for a primary alcohol, you look at the OH group, then you ask yourself which carbon is bonded to this OH group and how many carbons are bonded to that carbon. 1, primary alcohol. You look at the OH group, which is this one, and look at the carbon that is bonded to the OH group, then ask yourself how many carbons are bonded to that carbon, which is 2, becoming a what? A secondary alcohol. Then now you look at this carbon, you look at the OH group, which is this one, then now you ask yourself which carbon is bonded to this OH group, it is going to be this one, then you ask yourself how many carbons are bonded to this carbon, 1, 2, 3, therefore it becomes a what? A tertiary alcohol. Thank you so much. I hope I've achieved my lesson goals, whereby I wanted us to know what is an alcohol, how to do IUPAC naming of an alcohol, and also to distinguish between primary, secondary, and tertiary alcohol, and how do you know if an alcohol is primary, secondary, or it is tertiary. Thank you so much.